All right, let's dive right in. So, what I've got here is the source for today's explainer. It's a design guide from Texas Instruments called Op Amps for Everyone. And I know what you're thinking. A technical manual? Seriously? But trust me, hiding inside this super dense guide is the story of a tiny, unsung hero of the entire modern world. Right in the forward, it makes this really bold claim. It says the book is for everyone, from a relative novice all the way to an analog guru. Now, hold on. How can one book possibly be for a total beginner and a seasoned expert at the same time? That just doesn't sound right. It's a puzzle, right? And it's one we're going to solve together. So here's our mission. We're going to take a guided tour of this book, not to become engineers overnight, but to decode it, to really get what this little component, the op amp, is, and why it's so ridiculously important that a guide about it would be called For Everyone. To get there, first we've got to understand the core problem that all electronics have to solve. And it all starts in this world of incredibly weak, faint signals. I mean, just think about it for a second. How does the sound of your voice, a physical vibration in the air, get understood by your phone? Or how does the temperature of a room get turned into a number on your thermostat? There has to be some kind of translator. And this just nails the challenge. On one side, you've got the real world, and it speaks in these tiny electrical whispers. A faint voltage from a mic, a little change from a light sensor. But on the other side, you have our digital computers, and they operate on a powerful, confident roar of strong, precise signals. So how on earth do you turn that whisper into a roar? Well, you need a magic box, an amplifier. And the hero of our story today is maybe the most elegant, most versatile magic box ever invented, the operational amplifier, or, as everyone calls it, the op amp. So what is this thing? At its heart, an op amp is like a perfect, super intelligent volume knob for electricity. It listens to a tiny, weak signal and creates a much, much stronger version of it in a way that's totally predictable and controllable. The idea is so powerful, in fact, that Chapter 3 of this guide starts by imagining a perfect, flawless version, the ideal op amp. And this ideal op amp follows just two simple golden rules. First, it can measure a signal's strength without changing it at all. It's like a perfect spy, listening in without anyone ever knowing it's there. And second, and this is its whole reason for being, it constantly compares two inputs and does whatever it takes with its output to force those two inputs to be the exact same. It's completely obsessed with creating balance. And with just these two simple rules, you can build almost anything.
Yeah, because of those two simple rules, the op amp is so much more than a volume knob. It's more like the ultimate electronic Lego brick. You can just snap it into different configurations to build totally different things. Let's just peek at the book's table of contents for a second to see what I mean.
Okay, for example, get this. In Chapter 3, you wire it up one way, and boom, it becomes an adder. It's a tiny analog computer that can literally do math. It adds electrical signals together. Now let's flip way over to Chapter 15. You use the exact same Lego brick, just arrange the parts around it differently, and now it's an oscillator. It creates a perfect repeating sine wave, which is the fundamental rhythm behind everything from music synthesizers to radio. Then check out Chapter 16. Same brick, new job. Now it's a filter. It can listen to a messy, noisy signal and just perfectly slice out all the static and junk you don't want, leaving you with just the clean signal you need. And finally, in Chapter 12, we see its most important job. It's the perfect bridge. It's that translator we were talking about, taking those weak whispers from real-world sensors and making them clean and strong enough for a digital brain to finally understand. It connects our world to the computer world. Okay, so if the idea is so simple, just two golden rules, this one Lego brick, then why is this book hundreds and hundreds of pages long? Well, that's because there's a huge, huge gap between the perfect idea of an op amp and making one that actually works in our messy real world. And this, right here, is where things get really interesting. The ideal op amp has infinite power, but real ones can become unstable, which is a whole thing in Chapter 5. The ideal one is perfectly silent, but real ones are noisy. That's a whole Chapter 2. The ideal one is instant. The real one has speed limits. All of these tiny imperfections, all these real-world trade-offs, that is what fills this entire book. And honestly, this is where the real genius of engineering is. It's not just about knowing how to use the Lego brick. It's about deeply understanding all of its little flaws and quirks, and then designing around them to build something that's still precise, reliable, and just elegant. So let's zoom all the way out. We've seen the problem, the whispers. We've met our magic box, the op-amp. And we've seen how complicated it is to bring it to life. So what does this all actually mean for you? It means the op-amp is literally everywhere, hiding in plain sight. It's in the headphones you listen to music with. It's in medical devices that save lives. It's in your Wi-Fi router, your car, your phone. It is in basically every piece of modern electronics. It's the invisible workhorse, the unseen giant, constantly translating and filtering and amplifying the world for us. And that brings us all the way back to that puzzle from the beginning. Why is this book for everyone? Because the op-amp isn't just for electronic gurus. It's the fundamental building block that makes the technology that everyone uses possible every single day. The novice has to understand its magic, and the guru has to master its messy reality. So I'll just leave you with this thought. The op-amp is just one of these unseen giants. A simple idea that's so vital and so complex to actually pull off that it quietly ends up shaping our entire world. It makes you wonder, right? What other hidden heroes are out there, just doing their job, waiting to be explained?